Okay, we are going to talk about measuring electricity. So in the past couple of days, we've talked about static electricity, we've talked about electrical circuits and how electricity travels. We know when you set a circuit up with a battery, it travels from the negative end to the positive end. So now we're going to talk about the ways that we measure electricity. And when you really see that is when you're looking at batteries or when you're looking at light bulbs, things that use electricity. So we're going to talk about volts, we're going to talk about amps, and we're going to talk about watts. Those are three different ways that you can measure electricity. So the first one is volts. So what they do is they measure the force or the pressure of the electrical current. So how much force, how much pressure is that electrical current pushing? So if you think about it, you think about a 9-volt battery, which they're like the little rectangle ones that a lot of your toys might use. They've got a pretty good amount of power. They've got a pretty good push. But then if your mom or dad or grandma or grandpa uses power tools at home, like maybe they've got a cordless drill and it's got one of those big batteries that they sit on a charger, it's normally an 18 or a 20 volt. So that means it's going to push a lot more power. It's going to put a lot more pressure through that electrical current, so it's going to be stronger. So the more volts, the more electrical current that is pushing through. When we talk about amps, it's the amount of electrical current or the amount of electricity used. So however, the amps would be the amount of electricity that is needed to run something. So more amps is more power. This one, watts, is something that you've maybe seen, like if you've gone shopping for light bulbs before, but not really understood what it means. Watts measure how much work electricity can do per second. So how much work per second can that electricity do? So if we look at these light bulbs, we have a 60-watt light bulb and a 75-watt light bulb. So we know watts are how much work the electricity can do. So more watts is more work. So when you've got a 60-volt light bulb and a 75-watt light bulb, I think I said volt, I meant watt. When you've got a 60 or 75-watt light bulb, the 75-watt light bulb can do more work, so it's going to shine brighter. If you want a light bulb that's going to light up your room super bright, you want to go high watts. But it shines brighter, but it's using more electricity and making a brighter light, so it costs more money to use higher watt light bulbs because it uses more electricity. So if I don't really care how bright my light bulb shines and I want to save money, I want to pick one that's a lower watt. My 60-watt light bulb is still going to put light off, but it's going to be more cost effective. Lower watts are going to be lower cost, but it also means that your electricity is not doing as much work. So if you want a light bulb that shines super, super bright, you want to go with higher watts. If you don't really care how bright it shines, you just want to save some money, you want to go with your lowest watt possible.